I can start.
Yes, sir. We'll invite you. We'll share the flow of event also with you.
No, but I wanted because usually there is an introduction.
Yes, sir. Right now. Okay, sir. Sir, namaskar. I think namaste has been accepted as a global greeting, sir, irrespective of the time. So I welcome today's speaker, eminent speaker, Dr. Balas, who is from Romania. I also welcome Dr. A.P. Vyas, who is Dean, School of Engineering, Indrashil University. Dr. Sumit Chaudhary, who heads Computer and Computer Science Engineering Department. I also welcome Mr. Bhavesh Jain, who is assistant professor in Computer Science and Engineering Department, and Ms. Jyoti Srivastava, who is again from Computer Science and Engineering Department. And to all our audience, who actually are students of Indrashil University as well, all are welcome to this webinar. This is the third lecture in series of advanced and recent technology in the field of computer science and engineering towards Atmanirbhar Bharat, that is self-independent India. And it is sponsored by Guch Coast. Today, we have eminent speaker. Again, I spell him F. Sir, correct me if I spell it wrong, Dr. Balas from Romania. And he is going to speak on the parallel shift. So I share, for the sake of Dr. Balas as well for the audience, the flow of the program. We will begin with opening remarks from Dr. A.P. Vyas, who will also set the objective of this webinar. Then we will have brief account of Indrashil University, which will be covered by Vyasar again. Then it is imperative and courtesy to share the credentials of the key speaker today, and that will be carried out by Dr. Sumit Chaudhary, followed by your expert session, sir. The spotlight will be on you, sir, then. And then we will have question answers if there are any from the students, from the participants. And finally, we'll have concluding remarks from Ms. Jyoti and vote of thanks from one of the students. So that is how, sir, I've shared the flow of event with you. So beginning with opening remarks and setting the context, I invite Dr. A.P. Vyas, sir, to please share his remarks.
Thank you, Dr. Namrata, and good afternoon to one and all, and a very good morning to Dr. Balas. He is from Romania, and morning is there, so very good morning to him. Actually, sir, this webinar series is funded by the Gujarat Council on Science and Technology, and it is a very much need of time, I can say, the advanced and recent technologies in the field of computer science and engineering towards Atmanirbhar Bharat. Why I'm saying Atmanirbhar Bharat, the reason being our beloved Prime Minister, Mr. Narendra Modi, has given a statement and also vision for the self-dependency in India itself, and that should be increased. So IT computer can create a miracle in this direction when it merging with the other core branches like mechanical, chemical, electrical, civil, even electronics and communication also. And just to create an awareness regarding all these things, how computer science and engineering can help in creating Atmanirbhar Bharat, this webinar series has been put up. So I'm sure with your expertise, with your wordings, with your knowledge and information sharing, our students and participants will get benefited out of it, and they will definitely understand that how that knowledge can be utilized to create Atmanirbhar Bharat. At the same time, just to in benefit of you, sir, I would like to give a brief about the Indrashil University. So with your kind permission, I would like to share the screen and will show you the PowerPoint presentation about Indrashil University. It is a very brief presentation. So just you can see that Indrashil University, and we welcome you, and Kedila Pharmaceuticals Limited, that is one of the largest privately held organization, which is a parent organization for Indrashil University, and they have taken it as a part of their CSR under the educational initiative. And the name Indrashil is motivated behind the name of our current CMD, Dr. Rajiv Modi. Of his parents' name were Indravadan Ambalal Modi and Srimati Sheelaben Modi. So from that, the name Indrashil University has been taking place. And at the same time, I would like to say that Indravadan Ambalal Modi was truly nationalist by heart, and his aim was to create, to develop, to produce affordable medicines for the Indian public. And that is why he was known as the medicine man of India. He started his company Kedila Pharmaceutical Limited in one village, Hansot, near the Bharuch district in the state of Gujarat in India in the year 1951. And he initially was selling it on the bicycle, roaming here and there to sell his product. And over a period of time, with his enthusiasm, with his strategy, with his honesty, with his dedication, commitment towards the business and at the same time towards the nation, right now the Kedila Pharmaceutical Limited is one of the largest privately held organization with a presence in more than 90 countries and employees counted more than 10,000. So to honor their legacy of care and compassion, the university's governing body and Dr. Rajiv Modi are determined to holistically transform and develop the university into a hallmark of global academic excellence. So here you can see the success milestone of the Indrashil University. As I said, in 1951, the Kedila Pharmaceutical Limited started in 2016 as a part of CSR, the educational initiative taken by the Kedila Pharmaceutical Limited, widely known as the CPL, under the banner of Sri Saraswati Education Sansthan, started this institute. And in 2018, it was fully placed state private university of Gujarat, and it was the first of its kind life science university in India. So it is just a 2.5-year young university, and within 2.5-year young university, you can see the success milestone like Atal Innovation Mission, an initiative of Government of India, has sanctioned to start Atal Incubation Center at Indrashil University, which is a flagship startup and entrepreneurship incubator program. It is a very highly optimistic kind of the program of the government of India and well supported by the government of India. In 2020, that is March 2020, government of Gujarat has sanctioned the Indrashil Innovative Foundation, one more startup program for the student of Indrashil University under the banner of Student Startup and Innovation Policy Scheme. And in continue to this trend, in January 2021, we got the sanction from the Industries Commissionerate, Government of Gujarat, to establish Nodal Center for Incubation Cell at Indrashil University. So students can get use amount of platform, use a stage to come up with their ideas, to explore their skills. And we are having all kind of facility, 360-degree facility, working space, research laboratory, mentoring facility, funding facility, everything is available at one place. And these all development took place under the able mentorship of Dr. J.S. Yadav, who is a provost of Indrashil University. And at the same time, he is a mentor and director of research in Indrashil University. He is a former director of Indian Institute of Chemical Technology, Hyderabad, one of the highly reputed national research laboratory of India. And he is also a Shanti Swarup Bhatnagar Fellow and JC Bose National Fellow awardee. If you see the credential, he is having more than 150 plus patents on his name, more than 1400 publications, 250 plus PhD students. Right now, also more than 10 PhD students are working under his guidance. And out of 1400 plus publications, more than 27,000 citations are there. So he's a truly, and he is recognized as the world's top 0.2% organic chemist. So a very well-known personality at the Indrashil University. And we give focus on the 5 pillars at Indrashil University: academic excellence, industrial exposure, internship and placement, 360-degree development of the student, where that means it is a extracurricular, extramural, co-curricular, curricular activities, everything taking place at one place. Plus global education standards, because our syllabi is designed by the IIT people, by the scientists from national research laboratories. and it is at par with the international universities of USA, UK, Australia. And if you see the credit articulation, there is no much change in their credit articulation with our credit system. We are offering, right now we are running two programs, two schools. School of Engineering, where we offer BTech Computer Science and Engineering, Mechanical Engineering, Chemical and Biochemical Engineering, plus PhD. At the same time, under School of Science, we are offering BSc Honors in Chemistry and Bioscience. We are the only one who is offering BSc Honors in Bioscience in Gujarat State. Plus, at MSc level, we are offering Chemistry, Animal Biology, and Microbiology, and PhD. In addition to this, recently we have started offering one more program, postgraduate diploma in environment, health, and safety, considering the requirement of safety inspectors, safety instructors in the industry. It is a one-year trimester program. Plus, we are having international collaboration with Sacred Heart University USA, Tuskegee University USA, and University of Newcastle, Australia. We are having MOU to exercise student exchange program, student internship program, kind of the thing. In addition to that, at Sacred Heart University, we are offering dual degree program for the students of computer science and engineering. Under this program, student will be studying 3 years at Indrasil University, and last year they will be studying at the Sacred Heart University, and they will be equally eligible for higher study and work permit in USA. So this is a very good kind of the program where the degree will be offered by both the universities, Indrasil University as well as Sacred Heart University. Just to give a one top landmark instrument, analytical instrument available in our laboratory, rest are all available, you just name it. But one top benchmark instrument, that is the nuclear magnetic resonance spectroscopy at IU, which is costing more than 4 crore rupees. And it is widely used to determine the structure of organic molecule or quantitative analysis of the mixture containing known and unknown compounds, or to determine the molecular conformation in the solution. So it is in very high demand, and we are the first university in the state of Gujarat who is having a such kind of instrument at university level. So other instruments, you can see HPLC of different make, TLC UV is there, FTIR is there, GC is there, GC mass is there. You just name the instrument, all are available at our place. And as I said, we are having AIC IAC Foundation, Indrasil Innovative Foundation, and ICIU, that is the innovation cell, is also available. And as I mentioned earlier, the candidate or the incubatee will get the world-class R&D laboratory access, plus dedicated office, lab, and workspace, plus provision of rupees 50 lakh kickstart support. In addition to that, rupees 2 crore seed fund support. And still, if they need some amount to start their project or to establish their company, then we have tie-up with the Gujarat Venture Financial Limited, where they can get the funding. In addition to that, you can see we are having a very good tie-up with the mentors, may it be from industry, government department, agency, R&D lab, free network access, plus 360 support for taking the startup to a sustainable business. And we are having presence on Facebook, you can say Twitter, Instagram, and if anyone is interested in startup or in knowing more about the university, our contact details are shared with all of them. So I hope, sir, you got the brief idea about our university, how we are functioning, and what kind of programs we are offering. So once again, welcome to the Indrasil University, and we wish to have strong bond with your university also in future in benefit of the students. Thank you very much.
Thank you, Dr. Vyas. It's time now to put on record the credentials of our key speaker today, Dr. Balas, and for that I request Dr. Sumit Chaudhary to please share the credentials.
Good afternoon, one and all. Myself, Dr. Sumit Chaudhary, Head of Department, Computer Science and Engineering, School of Engineering, Indrasil University. First of all, I'm very thankful to Professor Balas for accepting our invitation, for giving expert lecture on the parallel shift, for our under webinar series on advanced and recent technology in the field of computer science and engineering towards Atmanirbhar Bharat. Now I would like to introduce our today's expert, Professor Balas. Professor Balas is IEEE senior member and currently full professor at University of Aurel, Vlaicu of Arad, Romania. He is the author of 4 books, 14 book chapters, 83 indexed articles, 40 papers in other journals like international and national journals, conference proceedings, and 7 invention patents he got with his name. His research interests are in electronic circuits, modeling and simulation, adaptive control, intelligent and fuzzy systems, greenhouses, and intelligent transportation. The main original concept introduced by Professor Balas are the fuzzy interpolative systems, the passive greenhouse, the intelligent rooftop greenhouse, the constant time to collision optimization of the traffic, the imposed distance braking, the internal model branch casting, PWM inverters for railway coaches, the rejection of switching controllers effect by phase trajectory analysis, etc. He has been mentor for student research challenges awarded by Microsoft Imagine Cup, GDF, SUSE, etc. So once again, I welcome you, Professor Wallace, and I request you proceed for your session. Thank you, sir. Thank you, ma'am.
Sir, could you please, Dr. Balas, if you can unmute yourself?
Yes. Okay. Thank you very much.
Thank you, sir.
And I will begin to share the screen. I hope you can see.
Yes, sir, we can
Yeah,
see.
yeah.
It's very
And
clear.
I will make the presentation like this. Okay.
Yes, sir.
So the parallel shift. Great development plans need above all a vision. Atmanir Bharat, excuse me for my mistakes, has the vision. Then there is a need for thorough analysis, difficult to perform given the complexity of the system formed by a large country like India, rightly called the subcontinent. So such an analysis can only be made up to a certain level of detail, and they must be able to capture at any time the overview. That is very important. The coordination, it's very important in such big plans. In this presentation, we draw attention to system engineering with various examples, especially from computer science and engineering. Now, system engineering. When I was a student, and after that, I had in my mind a rank, a top of the best companies I used to like and to appreciate. On the first place here was Bell Telephone Laboratories, which in fact created electronics. Yes, they were creating. They created the electronics as we know it, and the NASA and the U.S. Department of Defense, but especially NASA. I was following the landing on the moon. It was amazing. I was very proud and very interested. So I think you know there are some legendary persons who came out of Bell. Hendrik Wade Bode, or Bode, I don't know exactly how it's spelled. Harry Nyquist, the Nyquist criterion. Claude Shannon, the sampling theorem and the information theory of Claude Shannon. And on the other side, at NASA, it was the personality of Werner von Braun, who was the brain who managed to coordinate the Apollo program. So 70 missions, I think. They were on the moon, they came back, and everything was sensational. Now, why I did make you this introduction? Because system engineering issued out of Bell Telephone Laboratories in the 40s, and then later by NASA, okay? The basic ideas of system engineering can be very, very well, I don't know exactly how it's the stage in your university of teaching system engineering. I perhaps my presentation is a little bit too simple. Well, if you will be so kind to tell me to adjust a little bit, to give me some reactions, it will be very nice. Now, the basic idea: the properties of a system as a whole may greatly differ from the sum of the parts properties. So system engineering embraces a holistic view. On the other side, of course, system engineering is fundamentally interdisciplinary. Engineering, but also management, economics, world knowledge, even psychology. There is a place for any scientific or technical discipline here in big projects, no? The first case study that I will present you, it's well known in Japan. It was about the Sendai Metro. Sendai, it's a town, very big town near Fukushima. So Fukushima, it's a side of Sendai, and they in 80s they wanted to develop a metro network, and they bought the best possible tramways or wagons, which had the GTO thyristors for brakes, active brakes, which were also saving a lot of energy, and all the best was in these wagons. And the first segment was nice. It was working very nicely, and then problems begin. Yeah. Why? When several or two, actually it was enough, when two wagons were accelerating in the same time, there were not enough energy in the network for both of them, and so the tension was falling down. Or when when two or more wagons were braking, yes, the regenerative braking, it's okay, but it's injecting the movement energy into the network. So if two wagons were braking in the exact same moment, it was an over voltage on the network. So problems, and they lost at least 2 years trying to solve this problem. I will not insist too much until Professor Michio Sugeno gave them the idea to use the fuzzy logic in the coordination of this network, in the sense that they renounce to the very precise, very sharp schedule. You know, Japanese are very precise. No, they had to draw down the precision, and the idea was that the fuzzy logic was coordinating such way the network that when the wagon was supposed to accelerate, it was waiting for another one to brake, to brake and to stop. Of course, there were some tens of seconds of delay or advance, perhaps, but in the end, the network was working. But you can see this idea of holistic approach. You should take and study and work with your products and on this kind of approach, which is called sometimes top to bottom approach. So as you see here, the solutions, the fuzzy logic. Anyway, I will not insist. I think it's very clear. Now, system engineering is a discipline that begin to take power, especially after NASA contribution, and they have a lot of there is a lot of ideas that are proposed by system engineering. For instance, you see here terminology. See, high comprehension but low resolution, super system, segment, element, subsystem, and high resolution and low comprehension, piece, subassembly, assembly. An important branch of the system engineering is the software system engineering. Software systems engineering. I think you're teaching this discipline in your university, as far as I know. And look, these principles, this idea of examining a system from top to bottom is possible even at the lowest degree. Look here, top to bottom approach means, for instance, supervision. Yeah, supervision, it's from top. Omron, it's a Japanese control engineering company, has introduced this adaptive PID temperature control, which is supervised by a fuzzy supervisor. So the principle is fundamental. We can work with it at any level. But of course, it's more important to work at high level. Now, look here, some products that were conceived and developed having in mind system engineering. The International Station, and especially the A380 Airbus, which is the biggest possible plane, and this plane was had no prototype. It was 15 million parts were designed and tested by simulation on a big supercomputer. And the idea was that if you're making prototype, this prototype will be cannot be very similar to the production, to the line, to the plane produced by the line. And the first line, the first product was from the line, and they were making 2 or 3 years tests on that plane. Meanwhile, the plane was exploited in Singapore. Well, it was not so easy, and they had some problems, especially with the connectors, because the connectors were not enough tested, and they had some chattering, and well, it was a disaster financially. For 2 or 3 years, they had to replace all the wires of the first planes, but on the other side, the plane is perfect. Perfect, well, it's very good. It's very safe. I was very happy to travel with such plane once and come back. Of course, I had 2 flights, and it's very nice. Now, here you can see the main contribution of NASA. This systems engineering handbook, issued for the first time in 1995. Then this is this is a new edition. It's rather changed, but the main ideas are still there. And I can suggest to any engineer to download this, because it's you can download it from the net for free, and to try to study and to try to get some ideas from here. These ideas are very, very true, very productive. I had in my life a previous experience on engineering in communism. We had no NASA handbook. Even the handbook was not written, and I could take some conclusions for my work. And when I found that book, I realized that those conclusions I checked myself was very true and very helpful. I will come back on this. Basic tools and concepts. System modeling and simulation. This is very important. The simulation and the system modeling, it's the best tool, the most important tool of system engineering. System architecture, optimization, system dynamics, system analysis, statistical analysis, and so on and so on. Now, an idea which is very important to deal with is the trade-off between effectiveness and cost. You see, there is a curve of the dominant solutions. All possible designs are under this curve. Above this curve, there are the technology which is represented here is not enough, has not enough power to work on this. So this region is out of our reach. Now, this is very important to know this curve for each new project, to know which is the best version of my my project. What can I expect and what can I not expect? But you see, you will find very, very few people disposed to communicate you the this curve. So usually you have to make your own analysis. You make this analysis and you can find your project is somewhere here, and then you want to improve it either by improving performances at the same cost, or preserving the performance but at a lower cost. This is the usual way of working in system engineering, but not only in system engineering. This is not a tool only for system engineering. It's very important to think like this. And you see here, these are those strategies. It's interesting that they recommended to apply those strategies, not to apply them simultaneously. So the idea is that if you either want to improve performance or to reduce costs, not to mix in the same time, not to try to tackle those problems in the same time, because you will not know for sure if your program of measures is good and it has efficiency or not. The only possible way to improve this solution, it's of course innovation. Only by innovation you can push this curve up, and you can in fact, you can improve your performance of your project. So innovation. Now, other ideas which are very typical and followed by system engineering. Look here, it's the life cycle approach. So you approach a product by its life cycle, and this life cycle should be supervised at each level, and it must cover all the phases, from the requirements, the discussions with clients, design, execution, testing, and release, and even the take out the products after years of working, and to deal with the toxical components and so on. Here you can see the V-shaped model in which you see the implementation stage is very important. Something here. So you take this region and you make a V. And what is the idea? You can here it's an ASML, a last generation lithographic system at for circuitry at 5-7 nanometers. So you're a company and you invested thousands of billions of dollars to make this technology. You replace everything from your company which is old, and you begin to work like this. When a client is coming to you, an old client, perhaps he's not even aware that you dispose of this technology, and then you have to explain the client that everything you are working now, it will be based on this technology. So even his requirements should be should be adapted. Usually should be improved as as a new technology has the meaning of improving the performance. And the same here. So you see, these are some system engineering ideas. And now the most important, which I was discovering myself, was the doctrine of successive refinement. So you see, you discuss with client, you identify and quantify the goals, you create the concept, the study begins, the project begins, everything is okay. But then you as a chief of the program, you must not leave the work. You must not wait and only look at the others. Try to identify the bottleneck in your project and try to improve it. So this will be the second cycle, and so on and so on. So you should work until the last day of the project. Now I had I know that India and Sri Lanka had some issues, have some problems in the past, but we were working in Arad for Sri Lanka. But I think Sri Lanka wagons are very close to Indian ones because you're in Commonwealth, and I think you still keep that 110 volts DC battery for supplying the wagons. And so the idea was that they needed at least 450 wagons, passenger wagons. And the problem was that the fluorescent lamps need an inverter, and those inverters, the free oscillators at the time, were not able to work without a lamp. If you would take the lamp out, they would overheat and perhaps even take fire. So then I introduced an invention. I changed that was in '86. I introduced a pulse width modulation inverter with only one transistor, and such way I could control the consumption and to avoid that overheating of the inverter while working without lamp. But after I identify and quantify the goals and everything was started, we had problems. In Sri Lanka, it was very hot, salty, humidity. So all the components had to be re-homologated in the TH3 standard. So you see, this was the second cycle. And in the end, I even have another last cycle, because we discovered that this inverter was not able to work in very hot atmosphere, and in a wagon that is kept with lighting on at sun during day, the temperature under the roof can be even more than 70 degrees. So I had to find a solution for overheating, and we found the solution of oxidating the aluminium radiators in black. The black color means an increased capacity of radiation. No, usually, sorry. Usually, system engineering demands a lot of experience, and it's not even taught at bachelor degree. Sometimes it's only beginning to be studied for masters or for doctoral programs or so on, because it needs they are demanding this discipline demand a lot of knowledge. But what is interesting that this knowledge can be acquired in a field, in a domain, and can be transferred in other domains. So it's not so important the domain in which you were working before, but it's important to work there to have that experience. Now, about the software needed in system engineering, you see here there are some diagrams. These diagrams are the most important tool of system engineering, and there are some special softwares which were designed for this. UML, for instance, UML, Universal Modeling Language, and you can see here some projects made by my students with Star UML, which is a Star UML. It's a Korean company which is offering this UML for free, and they are relatively easy to use. So unified modeling, not universal, unified modeling language, and you see other softwares families. This is the International Council on System Engineering, and here it's the another software that is using the bottom approach, but who can also work from bottom to top. It's not, you dispose of each approaches. So you see here the HDL, hardware description language, in which the architecture can be described as function or as structure. So this is a general approach which appeared in 86, 87. Why it's so important? Because you can describe a product, an equipment, complicated, like an economical program, for instance. You can describe it simply with a functional description, you see. So from top to bottom, and then, for instance, you're a company of which is designing electronic circuits. You take from your client the description, the functional description, and your job will be to to work and to find out the structural description, which can be then realized on silicon. Yes, and such way you can work in parallel with different teams, and they are not waiting for one for the others. They are working, and when all the structural descriptions are ready, which of course must follow the functional description very close, no, identically, then you have the project. Now, my experience in this field begin with works performed at the low level, at bottom level, a model for the, for instance, for the ABS brakes. But then, if you take this starting point and you try to develop it at a large scale and to project it from top to bottom, you can find very interesting and new approaches on your field. Now here it's, for instance, the imposed brake distance, braking model method, which is able to impose to a wagon to stop over a certain very precise defined braking distance. I will not enter into details. Here's the constant time to collision criterion, which again is able to overview, to coordinate the whole traffic on a highway. The idea is that you see the time to collision, it's a parameter, it's an index which is used in traffic analyze, and this constant time to collision criterion is able to impose to a vehicle the constant time to collision during all its circulation. Again, I will not insist, but in the end, if I finish the presentation, we can discuss it. We can come back and look better. Here you see this. Here we have three or several curves which represent the ideal distances between cars in highway for different time to collision: short, medium, long. Yes, and in the end, on a highway, we can circulate by CTTC platoons. Look here how it's working, such a platoon. Yes, these are the distances between cars. This is the phase of transition phase at the beginning of the circulation, and then all the cars which are following this criterion are entering into automate cruise controlled circulation. About this method, I only can say that I had a very, very, very nice surprise in 2013. lady from France, had her PhD, and in her thesis, she applied this method and another one, so two such criteriums. And also she was studying a human driver. She received a car from Renault that was in France, and she was studying the circulation in town, respecting this car following law. And she had a major discovery. She discovered that if in town you use this car following algorithms, which were designed for a highway, you can get 25 to 30 % of fuel economy. So you can run into the town at the same consumption at like outside the city, outside the town. So okay, now air conditioning models, they derived from our research topic derived from the car with the air conditioning installation, and then I developed this idea on some new concepts like passive greenhouses, or here it's the newest one, the integrated rooftop greenhouse or intelligent rooftop greenhouse. You see here, if this integrated rooftop greenhouse is connected to internet and has enough sensors, the idea here is that if a building has a roof, on the roof, a greenhouse, this greenhouse can be connected with the inside of the building. So you will be able to breathe oxygen-enriched air by the plants. And the plants will get from us our carbon dioxide, which for them it's a fertilizer. So thanks to this to our metabolism, very different metabolism, we can live together. We can. It will be very, very nice, ideal to have a symbiosis with plants, to live surrounded by plants, but this is not possible because we have not enough place. But you see this the phone is calling me. I will not respond. So I think this concept will have some development in the future, because it can help you, it can help us to improve the carbon dioxide offset in the whole world. You can imagine a town with all the roofs as greenhouses, and anyway, a roof is not very useful, and well, I work for this anyway. Now here it's the as I told you, simulation is everything here. This is the the model of that intelligent rooftop greenhouse is the temperatures on the roof greenhouse and the building, and here are the carbon dioxide and oxygen concentrations in the air. And here we have some simulations. Now look why these simulations are so valuable. Some years ago, 5, I think, we made a project named Oasis, in which the idea was to transform Sahara, the desert, into a vegetable garden. Sahara has very, very, very good conditions for growing vegetables. Can you believe this? You can grow vegetables on sand, and here it's the ocean, Atlantic Ocean. You can take salt water and take the salt out thanks to a greenhouse, again a greenhouse. And then you see here a complex system which has some tanks, water tanks, even fish. You can even make aquaculture here with fish, with plants and everything. But this project was not accepted because of some technical issues. This was the initiator, the main idea generator, the German architect Anton Rosbach, and now he's working in Mexico. He is hired at Guadalajara University, and he has seawater aquaculture desalination plant in Baja Peninsula, in Baja California, on that northwest extreme side of Mexico. And he was designing this kind of projects, and I think in the end he will have the success because he's deserving it. No, I will not insist on this because we must close to the main subject of our talk, because this was only the kind of introduction. By the way, how many time I have for my presentation? How many minutes I still you will listen to me?
Yeah, Professor Balas, actually we are running out of time, but if you have main topic, then you can discuss today, no problem.
Okay.
The main points you can discuss.
I will be brief. The global financial crisis of 2008 was the worst financial crisis since the Great Depression. But contrary to the assumption, which is logical, that during financial crisis industry weakens, IT, electronics, and computers witness revolutionary developments since 2008. Why this? High leverages before crisis are, of course, highly profitable for banks, especially. But they allowed the owners of the borrowed capital to influence the granted technological researches. Yes? Now look here, the best example is the electronic automobile. You can imagine, for instance, that Nissan is going to a bank and ask for some money to finance the development of a fully electrical car. But the bank is thinking like this: okay, but I gave much much more money to some conventional companies. And if this Nissan is coming with the pure electric, the others will suffer, will fall down. And I don't want this. So they will they will answer to Nissan like this, okay, I will give you not 10 million, I will give you 50 million, but make a hybrid car. I want there also a gas burning engine, okay? So after the crisis, when the financial world said to the industry, okay, boys, relax, we will lose some month, just have the patience to wait. And at that time, those who were able to build some projects were not forced, were not leveraged by the system, and they could introduce their own objectives and ideas on the better technical basis. So that is why after the crisis, after the financial crisis, the technological development flourished. Yes, this is not good. This is good. Now look, I will give you one example. Oops, sorry. Here it's a chapter which is very important for me, FPGA and HDL. Since TTL times, integrated circuits were realized starting from gate arrays, for instance, NAND gates, simply by executing the wired connections. The last connection, the mass programmable, this is the technology called the mass programmable circuits. Here is, for instance, an inverter in CMOS technology. You see here, there are 6 main masks used for producing this circuit. The last one, it's only the metallization, but this last metallization mask is giving the final schema. All the others are only producing that gate array. The final schema is given by this metallization, and they begin to work like this. They were producing the wafers, in which each chip is still not configured array, and they are waiting for the client. And when the client is coming and wants a certain schema, okay, they made the last metallization stage. So this is how it's working in the mainstream industry, electronic industry. Well, full custom design is possible, but in which you are working with all those 6 masks, and you produce a final circuit, and this is the best possible way, but it offers you the best performance, but it's very difficult and very time-consuming and very expensive procedure to work like this. Okay. Now, issued from the electrically erasable ROM memories technology, the electrically programmable logic devices replaced in the 90s the mass programmable logic. These devices need their arrays of logic gates to be configured by electrically programming. Such way they are reconfigurable. You just have to erase that first program and replace it, and can be used in a variety of applications depending on the programming. The field program is achieved by users by means of a specific software code, the well-known netlist. Xilinx is perhaps the most powerful company in FPGA, in field programmable gate arrays. In fact, they were inventing this circuit, and these FPGAs are now very much used in many things, in many applications like aviation, military or civil aviation. All the planes are working like this. So if they discover that they have a failure somewhere, they can only replace the board, which is programmed as it should be for that place. So it's very flexible and very convenient to use such FPGAs all over your plane. Almost all of them are of the same type, but FPGAs can be designed also for increased reliability, for cosmic or high atmospheric conditions. So they are resilient to cosmic rays and so on and so on. So that is why you will not find very easy advertising for FPGAs, because they have their clients and they don't need they need young people who are able to program FPGAs. You will see in short times why this is very difficult to achieve, and these programmers are very difficult to find. And that is why all the software produced by Xilinx, ICE Design Suite, and now Vivado are free. You can download and work with them freely. Of course, if you are engaged in academic in education, and they are looking for people who are able to program such things. They are much more well paid and looked for than other specialties in IT. We may see FPGA as a breadboard whose wire jumpers are replaced by software commanded switches. That is the philosophy. The software designed for this is the hardware description language. We mentioned it before. Well, here it's kind of presentation of the HDL situation in the world. As you see, in order to avoid private companies to manipulate this standard, it was IEEE Institute who's taking care since 1986, I think, of this standard, and things are going very nice. Now, why I'm so attached to the FPGA technology? Look, FPGA may be configured as fully parallel circuits. Look, here it's the conventional architecture, computer architecture, von Neumann architecture around the bus with data, address, and control, and here are the memories and the other peripherals. And here it's the FPGA. Have a look. We'll have a look. You see here is the logical block, that array. But this array is immersed into a sea, like in a sea of connection devices. Yes. Such way that each logical block can be connected according to our netlist to any other possible block in the FPGA. Look how it's looking, such a routing channel, and here it's the connection node. At each intersection of the routing channel there are such connectors. You can see here 1, 2, 3, 4, 5, 6 transistors, which can make any connection possible, like this, like this, like this, like this, like this, like this. So this way we can configure that logical block array.
Professor Balas, sorry to interrupt you.
Yes.
We have one lecture lined up. We have already overshot. If you can,
Yeah. In 2 minutes.
Sorry. Yeah, sure, sir. Sure, sir.
So parallel computing versus von Neumann architecture, it's obvious that parallel computing is better because in von Neumann architecture, for each instruction, you have to wait the other instruction to be finished, okay? So parallel, it's the main resource we have for the future, yes? These devices these devices are very different of the microprocessor or microcontroller or DSP. Instead of program operation, FPGA exhibit a programmed architecture. So FPGA, it's an electronic circuit, not a computing system. It's an electronic circuit. So the idea is that if you want to work it properly, with it properly, you know, your background should be rather on electronics than on software computing. Yes? But because these circuits can work fully parallel, this is giving us a new perspective on the next years. Now we are living crucial moments in electronics and computers. You see here, the Moore law has reached its limit. Moore law states that the number of transistors on a chip will double every 2 years or so, as well as the chip's performance. But this is not working anymore because we are getting close to the limits of the physical principle. So we are now working, there are people who can work with single electron transistor. We cannot get down the single electron transistor, isn't it? So the more than Moore strategy, it's interesting, there are some terms here, is changing the focus from the level of electronic devices to the whole application level. Rather than making chips better and letting the application follow, the designers apply a holistic top-to-down approach, starting with the application like this. A common notion now, it's the system on chip, SoC. So the parallel shift is guaranteeing, parallel shift means a shift to the parallel computing. Is guaranteeing the more than Moore law, more than Moore, so we are not focusing on devices, but on whole application for decades. Now, the problems with the parallel shift is that you should start the student education from zero, from scratch. Not people who are used with conventional programming are not will never be good parallel programmers. So this is now only now beginning to work in the world. People is very reluctant to apply this principle because it's difficult. You have to start from the scratch. But if India is now triggering a long-term development program, I think a good idea would be to try to embrace at least a part, perhaps a short part of your students to embrace this parallel visions. Now, the conventional the establishment was very reluctant against this, but in the last years, starting from 2015, Intel and Microsoft begin to work in parallel. Perhaps not as deep as the really specialized companies, but still they understood the necessity of the programming of the parallel computing. Rather, until that, the idea of using FPGAs was just to emulate conventional programs to FPGA, which is nonsense, pointless. The most important company here, it's the Maxeller FPGA Maxeller accelerator. It's a program which is hosted by a cloud, and they are able to take a conventional software and to turn it to parallel and to accelerate its functionality enormously. Look here, and this is the last example. The Morgan Chase Bank give them the task to try to work on that cloud, which is even the computers on that cloud are FPGAs. So Maxeller was able to accelerate 1,000 times the processing of the data of Morgan Chase, 1,000 times. And therefore, Morgan Chase tried to buy Maxeller technologies, but of course, Europe didn't accept this. They only gave them 20% of the stocks, and so Maxeller now has also some money, and you can expect from them very interesting results, and you can look for them on the net. Conclusions. I will give you only the red colored line. Investing now in parallel computing is a good premise for decades of top achievements in computers and electronics. So this is the end of my presentation. I'm sorry that I was a little bit too long.
Not at all, sir. Thank you so much. In fact, it was perfectly in sync with the line of our theme, that was advanced and recent technology, to which you have suggested, sir. Especially the parallel shift you have suggested, and especially when you said that this financial crisis is indirectly proportional to the technical progress which we actually see here. So that was amazing, sir. Simply superb. Now, without further delay, I invite Ms. Jyoti Srivastav for the concluding remarks.
Thank you, ma'am. Okay. Good afternoon to one and all. Am I audible? Okay, fine. First of all, I would like to start with thanking Dr. Balas sir for such a wonderful session on the parallel shift. Sir has started with views and visions of Atmanirbhar Bharat, and then he shared his knowledge on system engineering. Then sir has explained the basic ideas behind system engineering and how it is interdisciplinary. That is, it can belong to various disciplines like engineering, management, economics, etc. Then sir has discussed various system engineering terms like piece, subassembly, assembly, subsystems, elements, segments, supersystems, etc. Sir has discussed various tools and techniques and various concepts also of system engineering. At various places, I like the most, sir has given his own experiences as an example to clear the fundas of system engineering. Then sir further discussed fluorescent lamp inverter for Astra railway coaches, which belongs to Sri Lanka, in which he had discussed a problem that the system can't work without that particular lamp. And then he explained how this problem is resolved using successive refinement. Further, in detail, sir has discussed system engineering softwares like UML and HDL, etc. Various other topics are also discussed by sir, like computer models for vehicles and derived ideas, air conditioning models and derived ideas, financial crisis and technical progress, FGPA and HDL, that is hardware description language, is very clearly explained by sir. Overall, sir, it was a very wonderful session and very encouraging for all of us. Thank you so much, sir. Now, I would like to request Yash Punjabi, one of our students from Computer Science and Engineering Department, for vote of thanks. Yash Punjabi.
Yes, ma'am. Good afternoon to each and everyone present here. My name is Yash Punjabi, student of BTech Computer Science and Engineering. It gives me an immense pleasure to deliver this vote of thanks for this event to all the dignitaries assembled here. I would like to thank Professor Mauris and Balas for enlightening us with his knowledge. It gave deep insights into the topic and also revealed some interesting facts. The point where Dr. Mauris told us about effectiveness and the cost curve was very informative. I would also like to thank our Dean, Dr. Amish Vyas, HOD, Dr. Sumit Chaudhary, and our beloved faculty members for organizing this webinar. And also, thank you to all the students present here for paying attention and learning. Thank you.
Thank you, Yash. Now I invite Sumit sir to wrap up. And sir, the concept of Glosis Sahara was also amazing, sir. That yes, we can explore on that area too. Over to Sumit sir.
Yeah, Professor Balas, thank you. Thank you for accepting my invitation. Thank you very much. And
Namaskar.
really session was very wonderful. Even I'm telling you, ma'am, you know, we met each other on Facebook, and I invited Professor Balas to deliver lecture. And, you know, in a single term only, he was saying, yes, I'm accepting your invitation. That was the, you know, wonderful part with Professor Balas. Once again, thank you, Professor Balas, for coming and delivering the lecture to our students. And really, our participants are, I hope they are very happy to listen to you. And in future also, I'll try to connect with you, and we'll have session once again on, you know, another topic of computer science and engineering. Thank you, Professor Balas. Thank you.
Have a nice day, sir.
I
Have a nice day, sir.
I would like to stay a little bit more, but my health is not very good right now, and I
Yes, sir.
I prefer
Please.
to take a nap or
Yes.
something.
Sure, sir. Stay safe, sir. Stay healthy.
So,
We wish
goodbye,
you that.
and
Goodbye, sir.
looking for the future.
Yes, sir.
Bye.
We must look for the future
Yeah,
together.
definitely.
Definitely. Thank you, sir. Namaskar. Namaskar.